Hi, gang. Dr. Mitch Earlywine, Clinical Research Methods, APSY 736. We're going to talk about a few strategies for sidestepping some self-report biases in self-report surveys and the like. This is really all about studying relatively controversial behaviors. We're going to go slowly, take our time, rest, wait for things to pop. If you want to listen to this on double time, I understand completely. But the clincher is to really be able to understand. And I'm not at all concerned about hair splitting with the computations. I want you to understand the methods. We're going to get into who cares. I'm going to talk a minute about some of the dispositional trait measures we've tried to use in the past to just see if some people are more or less likely to report accurately. I think that gets into some intriguing construct validity issues. And then we're going to talk about some strategies that have been employed to essentially make it so no one actually has to fess up to the controversial behavior, but we can still get an estimate of the base rate, and we can even, through a sort of latent class kind of approach, get some estimates of the correlates if we want, but it's going to rest on some assumptions. I'm going to tell you right now, you're going to need often multiple groups, very large samples, and you're going to have to believe that a lot of people are really lying on these, or it's not worth going through all the effort. And I'm just going to walk through how humbling that can be. It's not that I think everyone is utterly truthful. It's just that our efforts to detect if they are or not are often rather indirect at best. So as I've emphasized throughout the semester, love is boundless, but we're all a little apprehensive about fessing up to certain sensitive behaviors, even on self-report measures that are allegedly guaranteed to be anonymous. As we've been moving to internet surveys, I think some folks have appreciated the perception of anonymity. Others have grown even more suspicious given some of the wild legends we hear about the internet. A fun meta-analysis that came out just a couple of years ago suggests that we really do have some advantages with these item count type techniques, and that random response technique is also pretty reasonable. Obviously, these can vary pretty dramatically. If there's a chance to identify a moderator of this effect, it's certainly intriguing to do so, but you need very large samples. And more than anything, it's important to understand that from an ethical perspective, people are representing a community or a subset of individuals when they respond, even if they personally are not sort of outing themselves on these controversial behaviors. So we want to keep that in mind as we explain in our consent forms, not that anyone has ever read one. And so let's just be mindful of informing participants that if they, fill out their demographics and identify themselves in any way, they are often representing that very group. Obviously, the disparity between standard anonymous responding or direct questioning and what are essentially these item count type measures is really going to depend upon the content, on often the base rate of the purportedly controversial or sensitive behavior. And it can go in either direction. People might underreport some behaviors but overreport others. So Amy Starosta and I did a study on condom use, and what a surprise, people tended to overreport that. Joe Labrie and I have a condom use with alcohol combination, and yes, people do seem to claim to do that markedly more often than they would if they're responding in a more anonymous or item count kind of way. And large meta-analytic approaches suggest that getting at the truth on these really can vary with some of the moderators you would guess. So I'm going to describe this so you can listen to this video while you're chopping your vegetables, but feel free to put me on double time as you see fit. On these, you'll notice the dashed lines are for folks who identify as female, and they're aged from 20 to 70. The undashed lines, the solid lines, are the men, and these are just the disparities between the item count approach and the direct questioning approach for each gender. At least the way this is laid out, it suggests that women seem to lie a little less than men do on at least the behaviors that we tend to consider sensitive or measure as controversial, and that as women age, they are less likely to bother with any sort of self-presentational bias. And after watching my mother reach age 60 and certainly not give a shit what anybody thought, I think the veracity of her self-reports was pretty impressive. What are we really getting at? I'm talking about controversial behaviors like the examples I've listed, but any, illicit drug use, even extreme use of illicit drugs, sexual behaviors that some folks would consider deviant or at least low base rate, things along those lines. Historically, our attempts often began with things like social desirability. In the 60s, Marlowe and Crown developed a social desirability scale, an attempt to really get a feel for this construct and then use it as a covariate when interpreting data on these controversial behaviors. I'm often befuddled by this, though, because socially desirable responding may not be a response bias so much as a construct. People who claim a lot of social desirability also are less likely to certainly drink a lot of alcohol, use cannabis, and things like that. And it may be in some ways sort of a temperament. That scale was at one time very popular, as seems to be losing its popularity over the years. Subsequent work is on the balanced inventory of, I can't remember it right now this second, but the approach has been to suggest that maybe there are certain strategies people use not only to manage impressions of them, so certain behaviors that are involved with how much they present themselves to others, but also a sort of self-deceptive enhancement. And I think you can get a better feel for the construct as you get a feel for some of the items, and I'll get into those as we go. I do want to emphasize that the topics can go in either direction. So safe sex behaviors, drug use, misdemeanors, prejudices. Nadine Rayburn and I have one on anti-gay hate crimes and things like that. But also on reported base rates of pro-social things. So a recent one came out, usually encourage friends and family to pick up their litter. And in the item count approach, we find that this was actually markedly less frequent. Some focused work on basically samples of people who behave in violent ways in the name of political action. So they report virtual interactions with extremists online, and they actually seem to report that at a different rate than in the standard anonymous versus some of these item count or unmatched count or random response techniques. So some typical Marlowe Crown social desirability items include, I have never felt that I was punished without cause. And these were true false when this was first validated. I have seen it done sort of 1 to 7, which I find particularly intriguing. I sometimes think when people have a misfortune, they only got what they deserved. Well, if you can say, oh no, I've never thought that, perhaps you're behaving in very socially desirable ways, and your responses to items about alcohol consumption, ketamine use, etc., might be a little suspect. I am sometimes irritated by people who ask favors of me. Who's going to say false to that? I certainly commend you. Obviously, these are not as sophisticated as they may have seemed in the 60s when these were first generated. The lie scale on the MMPI tries to, take a comparable approach. I think over the years people have been a little more candid about this sort of thing, and truth be told, I think that's great. So the fact that we're actually permitted a bit of negative affect, irritation, occasional limitations, I'm proud of us as a society for making it so it's okay to say that you do feel these ways sometimes. In some ways, that's a sign of progress. For the balanced inventory, we've got 2 subscales, the self-deceptive enhancement one, which I find intriguing, and I'm curious about the discriminant validity with things like narcissism or overblown self-impressions. But one of the items says, I am completely confident in almost everything I do. Well, wouldn't that be delightful? I never regret my decisions. Someone is neither Jewish nor Catholic, I guess. I always know why I like things. Yes, wouldn't that be an intriguing way to go about life? And I am fully satisfied with myself. All right. Now, obviously, no individual item is necessarily a sign of sort of self-deceptive enhancement, but a high score on multiple items like this might at least be intriguing to look at as a correlate of some other behaviors. As you might guess, this developed in the industrial and organizational literature, but it's a very intriguing approach to getting at this sort of self-report bias. The impression management one I really also relish. So the item I never swear, as you can imagine if you know me, I just constantly say true to that one. I always obey laws even when I am unlikely to get caught. Yes, indeed. The law of the land is the law. I never read sexy books or magazines. I have never been selfish. So the originators of this scale suggest that people might not necessarily really believe these things, but in certain settings, they might endorse these as part of some impression management. And if they score highly on these, you might consider the other responses with several grains of salt. Well, one alternative to this, and in theory could even be used in addition, is the random response technique. And the strategy itself requires essentially trying to make the survey more anonymous than anonymous. So nobody is going to actually have to fess up to this behavior. They're going to have a randomizer of some sort. I'm going to use an example of a coin just because that's the handiest one. You might flip a coin if it's a sensitive item or not. You flip a coin for every item. If it's heads, you're just going to say yes no matter what. If it's tails, you tell the truth, right? So in the long run, on the average, the central limit theorem should kick in. We should be able to, again, if samples are large enough, assume that 50% of our yes responses are because someone flipped heads. And then based on that, get a fair estimate of the folks who were left who would have endorsed the controversial item as truth. I'm perseverating on the ethics, but do want to emphasize that people should understand. We are finding that at least the interviewers who use this find this approach very encouraging. Um, Steve Clark, when he was at Vassar, had some data suggesting people still lie this way, and so there is definitely a way to sidestep this by having two randomizers, one at 1/3 and one at 2/3, perhaps, something along those lines, to get an estimate of that. But truth be told, is still no guarantee of truth. But yes, as I mentioned, this is the random response technique. Again, we're going to just explain this up front. Now, having handed out 300 pennies to a large group of undergrads and tried to explain this strategy, I must confess it is not easy. Drew Anderson and I have shown that some folks, particularly the more shame-inducing, guilt-inducing behaviors associated with eating disorders, tend to be underreported, and people are a little more candid when they have this approach. But truth be told, again, it's no guarantee. Here was one that was performed on the internet. You can see they have this little random wheel. There's blue and red, and if it lands on one color or another, you answer accordingly. You might say, hey, if it's the wheel lands on blue, go ahead and tell the truth. If it lands on red, just say yes anyway. This one says, I sexually cheated at least once on a partner of mine in a lifetime. To say that never happened, well, good for you. And you can imagine, though, especially on the internet-based studies, people don't really trust that you're not monitoring. They don't trust the randomizer. So I'm less thrilled with how some of these have turned out. But it was an intriguing methodological approach. So just hypothesizing here a strategy where we might be asking, hey, have you ever used a psychedelic? Some anonymous estimates and big national surveys, at least in the US, suggest this is, at one time at least, around a 10% base rate. 10% of the people said yes. If we imagine a very large sample of ours with the random response technique and we get 57% say yes, what do we make of these data? And I just want to walk through it conceptually. You don't need to memorize the math, and in real life you can always go back and look all this stuff up, but I'm hoping it'll pop for you and you can get a feel for how it all works. So yeah, what's this 57% yes mean under these circumstances? Well, if half of these, basically if 50% of the sample, assuming the n is large enough, is because people flipped heads, then 7% of what's left must have engaged in the controversial behavior, in this case, the dreaded consumption of psychedelics. We're going to have to double that percentage to get the estimate, since only half the sample is answering that question. Actually, the other half is literally just having a coin land in a certain way. And then we're going to be able to compare our anonymous or direct questioning strategy to estimates from this random response technique. Now, essentially what we're really doing here is comparing two proportions. The z-test for comparing two proportions is actually, well, if you're a big nerd, it's very intriguing. But like any z-test we've seen, it's really going to be the difference between these proportions divided by the standard error of these differences. And this equation shows z equals, and then we've got letters and numbers and things like that, and it seems so overwhelming. But let's just take our time with this. This numerator is p hat sub 1 minus p hat sub 2. The minus 0 is obviously a little bit silly, but to show that the difference between these two proportions is what matters, but that we're dividing by this crazy square root of some other proportion divided by 1 over n sub 1 plus 1 over n sub 2. I'm hoping that over the years you're getting a feel for that this multiplying by 1 over n sub 1 plus 1 over n sub 2, this is actually how we pool a standard error across two samples, right? So if it turns out our anonymous group ended up being a little bigger or a little smaller than our random response technique group, that's okay. We're going to have p hat sub 1 minus p hat sub 2. We're just going to subtract those proportions and then get an estimate of the standard error of this difference, which is going to be the square root of essentially our sample weighted estimate of the variance. That's the standard error of this difference. Like every other z-test, it's really, a number, a value divided by our best guess of its standard error. Now, I call this slide the harsh master because, truth be told, even with random response technique, if we get a dramatically higher estimate of a controversial behavior, it probably isn't going to reach statistical significance unless it's pretty dramatic. So I just walked through some example ones here. If N1 and N2 are both 300, so literally we're running 600 people on this item. In the anonymous condition, we got a 10% estimate with direct questioning versus 14% with our random response technique, which seems like quite the difference, right? But the z-test for this, when you compute it as I described, is not going to be anywhere near the beloved p less than 0.05. In fact, at this base rate, it's not going to be p less than 0.05 two-tailed until the random response technique is 16%. So literally 60% or 6 percentage points higher. Now, as you start playing around with the distribution of these z-tests for proportions, you realize, holy cow, I don't have a sense for effect size in the way I would like, and I want to make sure there's some way to get this to work, or I'm not going to go to all the trouble of burning 600 participants this way. So Wimbush and Dalton suggested an effect size measure might be the RRT factor, or the unmatched count factor, as we learned that one. But basically, if the random response technique is twice as large an estimate as the direct questioning one, we'd call that a factor of 2. In our data, we've got 14% over 10%, so it's 1.4. Now, I admit no one would expect a two-tailed hypothesis test. Nobody's going to think people are less likely to report psychedelic. Well, actually today, right, it's getting kind of hip to say you've used a psychedelic, so perhaps it is certainly more conservative and even reasonable to assume in some settings. In my drug class, for example, I might wonder if some people might claim to use a psychedelic even if they haven't, just given the nature of the class. I also want to emphasize that the significance is going to depend upon the base rate itself. So the distributions are different depending upon the percentage in the standard anonymous response. So these are relatively low base rate estimates, 10% and 14%. As you move closer and closer to the 50% mark, things get a little more difficult for reaching the blessed p less than 0.05, but there is some consistency about it that I just want to walk through in a discussion of these distributional properties, just so you understand that the lower the base rate, lower base rates are going to have a different sort of distributional property than higher base rates. So here I've got 10% from the anonymous version, 14% from random response, with an N of 300 each. 4% are lying, right? If it's 15 versus 21, however, that is also non-significant, just as we saw. So that's literally 6% of the sample is lying, or so we're hypothesizing. And with an N of 300 each, it's still not significant. 20 versus 28, so the same factor, 1.4. We're saying that 8% of the sample is essentially lying. That does reach p less than 0.05, but only with n's of 300 in both groups. With 8% lying, 10 versus 18 is significant. 15 versus, oh, it should be 23. I apologize there. When there's an 8% difference, it is significant at p less than 0.05 when the n's are 300. And so in some ways, what you have to do is work backwards and think, hey, would I guess that 8% of my sample is failing to fess up about their psychedelic use? Now, unfortunately, as we're going to see later, what you guess may be a reflection of your own assumed similarity. And Dave Dalal in our IO program has actually used that as a way to try to get at some of these. But nevertheless, essentially, when you've got 8% lying and n of 300 in each group, you do reach p less than 0.05. So more than anything, I'm eager to emphasize we've got to think about our resources before we just reflexively start cranking out these kinds of studies. Obviously, we're going to need rather large samples, and if it's a population that we're intrigued by but is relatively rare, that's not going to be easy to do. So if our n is only 100 per group, I'm going to need, if the base rate is 10%, to have 20% estimate in the random response technique. And it's even worse with the higher base rate. So 40% versus 54%. Right? They're going to have to be 14 percentage points across as we get closer to the 50% mark. Do I really think 14% of the population is lying about their psychedelic use? Well, unfortunately, that would say something about my psychedelic use, so I won't tell you what I think. Nevertheless, if I'm feeling like it's not that big and I only have 100 per group, perhaps there's no point in really running a study along these lines. But I need to be aware that not only will my standard errors be potentially large, but the true score portion of fessing up to using a psychedelic is going to be markedly less than perfect. So bottom line, we really do need multiple samples for an anonymous group, a direct questioning group and a random response technique group, just to show that the strategy is working. If it does work, then I'm essentially capable of saying, hey, all these other estimates might be inaccurate and maybe underestimates for some controversial behaviors. People still lie, as I mentioned, that Clark paper. It's really old by now. But yeah, there is a way to try to get an estimate of how much people are lying if you have multiple groups with different randomizers. But more than anything, people really don't understand. It is cognitively demanding, even in undergraduates at a large state school. It's very difficult to get accurate responses, not because people are necessarily eager to lie, but because they don't quite understand the strategy. People don't trust randomizers. If you're flipping a coin yourself, okay, but even that, people get suspicious about. What are the big advantages? Well, it makes the interviewers happier. So if they know that they're using a random response technique with somebody they're interviewing face to face, they certainly seem to be a lot more comfortable about it all. It's Great when it works, but do you trust this estimate? Obviously, it would be better to have multiple strategies and see if they converge. And in fact, some of the best studies along these lines use direct questioning, random response, and the unmatched count. And so I'm going to turn that into a cheap segue to discuss the unmatched count technique. The unmatched count is even more grueling with sample size because now I'm going to have three groups. I'm going to have a standard anonymous group. Again, just like with the random response, no one is going to confess to any specific behavior. In fact, they're going to have a list of items and they're just going to say, of these items, how many are true? That group will have a control and a treatment, essentially. There'll be some folks who will get, for example, 4 rather innocuous things on the list, and the other group will have those same 4 items plus the controversial one. Obviously, if they just report how many of these are true, the difference will be our estimate of how many people are endorsing the controversial one. I have to emphasize the list items that you choose have to be mindful of the population you're surveying, and best to have something that would be somewhere in that 50-50 range, so nobody really has to say, yes, all 5 of these are true, because then they really are endorsing the controversial behavior and they might not be willing to. Nobody wants to say yes to all of them or they will be confessing. So one of my favorite unmatched count things actually was sampling a bunch of orchid enthusiasts. And folks got multiple items, but essentially they had some innocuous things about buying orchids at an orchid show, being a member of an orchid Facebook group, having some special kind of orchid. They've been a member of this orchid society where they were doing the survey for more than a year. And the other group adds, I have personally sent or carried an orchid across an international border without obtaining the required paperwork. Now, obviously, these are the folks who it's most relevant. Nevertheless, it seems that they're, the target ones, and folks might not want to fess up to having personally sent or carried an orchid across international borders without the right paperwork. And yeah, you'll be stunned to learn this came out in 2018, and people did fess up to this more using this unmatched count approach than they did in a direct questioning one. So here's a classic one where you have a list of 5 or a list of 6. This is from that Wimbush and Dalton classic on theft from work, basically. And they got this to converge. The random response technique and the unmatched count both confirmed higher base rates than the direct questioning for I was involved in the theft from my employer of cash, supplies, or merchandise worth 25 to 50 bucks a month. So I don't know if that meant like every month you stole 50 bucks, but basically the base rate was much higher with the unmatched count approach. How do we compute this? We'll get into it. But note that these are actually, because this study was done, I believe, in the 90s, some of the list items really would not work well today. So I would say that I can type reasonably well. There is at least one cordless phone in the house apartment where I currently live. And then the fact that they use this one, I mean, they were in Indiana, so of course I own 1 or more handguns. I mean, to me, in some ways, that's the more controversial thing. It may say something about my history of theft from employers. But I currently have 1 or more cats. That always works. Any sort of exercise behaviors. I have a sibling of some gender. I know what a balk is in baseball. I believe this one had, I read Harry Potter, and there was a time when that was certainly a 50% base rate. I doubt, I don't know, do people read books anymore? That would be delightful to think that they do. But you can imagine one crew is going to only have the 5 innocuous ones. The other crew will have all 6 of these. They don't report which ones are true. They just report the number that are true. We subtract those to get our estimate. So I was just trying to come up with some example ones here. I like to fish. I have at least one sibling. Blue is one of my favorite colors. I live with one or more cats. I exercise at least once per week. And the other group gets all of those, and I took a psychedelic substance at least once in my life. Well, the computations, again, will just be the mean for the one group minus the mean for the other. And that's our estimate, and we're going to compare using the proportions with that z-test again. I don't mean to belabor it, but I just think it's worth understanding. The computation is for a z-test for comparing two independent proportions. It's just the raw difference in the proportions, in this case, the anonymous or direct questioning version, and the estimate we get from the unmatched count, which is actually a difference between two other groups, divided by its standard error, which is, again, weighted by the n's for each of the samples. So in the Wimbush and Dalton, actually, they did this not for the 25 to $50, but for apparently ripping off only $5 from your employer. Doesn't seem to be quite so controversial. But they had 12.9% estimate in the standard direct questioning, 21% with the unmatched count, and I believe this one did pan out. But as you can see from the computations, it really does depend on their n. So with 100, probably not. Around 200, I bet so. If it's 500, I bet they could even make the delightful p less than 0.01. Who knows? What are the other take-home messages with this? I really encourage folks to have a control item with both of these and with the Crosswise paradigm that I'm about to describe, in part because we don't want a reviewer to just say, hey, maybe these samples are just different, or this technique is so weird, who understands it? I'm sure it's all just a mess. Well, if I've got one item that is on a comparable topic or within the same domain of subject matter, and it doesn't show any disparity across the two strategies, wouldn't that be in some ways a nice argument for the validity of the ones that do show the differences? So Dalton and Wimbush did something like, I think most theft occurs at night from employers or something like that. More people would use condoms if they were free is one I've seen used in some of the safe sex literature. So that it doesn't seem completely out of whack that you're asking this one, but it's something that really doesn't have a lot of controversy or social desirability inherent in expressing the attitude, and showing that that one is not showing a difference might be able to buttress my arguments for the elevated estimates that come up with the other strategies. Now, the last one is a little bit tougher, and I just want to make sure everybody's in a good space. If you need to take a break a second, get a stimulant of some sort, do whatever you need to do so that you can stretch your mind a little more, I'd be really grateful. The Crosswise technique essentially sets it up so we can use our entire sample, thank goodness. We're obviously going to have to show the validity by comparing it to an anonymous group as well. But rather than having to say, yeah, I did this terrible thing or this controversial thing, I'm just going to say, of these two statements, either one is true or neither or both are true. So take your time to wrap your head around this, and let me just read you the directions. In the following, you will be presented with two questions simultaneously, one regarding academic dishonesty and the other regarding your month of birth. So question A is, have you ever cheated on an exam? And question B is, were you born in November or December? All right. And they don't say which one is true. They say, yes, both or neither are true. Or, yes, exactly one of these is true, regardless of which one. All right? So if you never cheated on an exam and you weren't born in November or December, you pick yes to both or no to both, right? That top option, option A there. If you cheated on an exam but you weren't born in November or December, that's yes to exactly one. And you can pick that without actually having to fess up that you cheated on an exam. If you never cheated on an exam but happened to be born in November or December, you would again choose that yes to exactly one. All right. In the long run, on the average, we assume that a sixth of the population was born in November or December, and we'll use that as our base rate and try to compute essentially an estimate of how many people have cheated on an exam, given that we know that base rate for being born in November or December. I've seen some done in European countries where they literally went back and tried to figure out the age of the subjects and what the probability was of them being born in certain months and things like that. I find it computationally easier to use 3 different months just because I find 0.25 so appealing. I've seen folks do half the year practically. So whatever you think's going to work. The other option I've seen folks do is my birth date is even or my birth date is odd. In my lab, we were doing that as a randomizer for other things anyway. But just so that there's some question B that you know the base rate on. So the computations look foreboding because it's got a lot of weird Greek letters and italics and stuff like that. And more than anything, I just want to emphasize that this all falls apart if you pick something that is a base rate of 0.5 for the non-controversial one. So you don't want to pick 6 different months because that messes up the computations. But we're really going to try to get a feel for an estimate of this controversial behavior by knowing the proportion who gave the A response, the hey, both are true or neither are true, the known base rate of the non-controversial behavior, and we'll have to use our N to get a feel for the variance of this estimate. I just want to walk through that, but again, you're not going to have to come up with it from scratch or anything like that. Just want you to understand it conceptually. So here's the equation. Pi hat is really just our estimate of the controversial behavior. Little p here is our known base rate of our non-controversial behavior. And lambda is the proportion who gave that A response. Both are true or neither are true. All right. Now looking at this, you think, well, what is going on here? But if we think it through and just take your time, it's all going to be fine. So we've got lambda plus the known base rate of the behavior minus 1. Okay, let's think about what does that mean really. It's the proportion who gave that answer, both or neither, plus the number we would expect the base rate we would expect for the non-controversial behavior, minus 1. So it's how different is that from all of it, right? Divided by 2 times P, 2 times the known base rate of controversial behavior, minus 1. And that's going to be our estimate. So I might have a proportion who gave response A plus what I know is the base rate of the non-controversial, minus 1, over 2 times that base rate minus 1. And that's going to be my best guess for how common this is. But I also need some kind of feel for the variance on this. And I'll use that estimate and its variance in all my subsequent reporting. This variance equation looks absurdly foreboding, but really it's just turning lambda, pi hat, and the known base rate of the non-controversial behavior into some sense for how much this vary. So we'll end up having our best guess on the base rate of the controversial behavior times the base rate of the folks who didn't do that, right? Divided by n. So it becomes a proportion. And really, that is added to the proportion of the known base rate of non-controversial times the other crew. We do this like we do any other proportion or probability, divided by n times 2p minus 1 squared. That's going to help us essentially set the metric for this variance. And again, p cannot equal 0.5, but otherwise this is going to work out. Obviously, if you need help with this, just let me know. Some folks in Eastern Europe are pointing out that there may be some better ways to do this. We might want to add some corrections to this. But all in all, if this estimate over its... Well, we can compare this estimate to the anonymous group and see if the Crosswise is producing a more dramatic, a markedly more rare or a markedly more common estimate of the controversial behavior. All right. Well, what is the deal with this Crosswise business? You definitely still need the huge samples. It's high in cognitive demand. People don't have to compute the variance, but they still have to understand the instructions. The moderators have been identified. What a surprise. Education is a moderator of the disparities between Crosswise and direct questioning estimates. With some of the behaviors, though, I feel like education is a reasonable correlate. So cannabis use tends to increase in the college educated. I mean, the best way to keep your kids from smoking pot is to never send them to college. And that's an effect, not necessarily a product of some kind of self-report bias. Are they motivated to even go through the mental gymnastics of this? And culturally, these things really vary. So I'm not an East Asian, but there are certainly publications suggesting that East Asian humility can get in the way of the reports of some of these estimates of doing a good job at work, for example. So what is a controversial behavior in one culture obviously might not be the same in another. So I just wanted to wrap up with this notion of indirect questioning because Dave Dalal did this and I really love this, and I basically voted for him for tenure because of this paper because I love it. They again, in huge samples from the IO literature, they looked at comparisons for reducing deliberate distortions on some self-report measures of sensitive constructs. Now, again, it's that IO literature. So it's, do you skip work? Do you, call out sick when you're not really sick? That kind of thing like that. The take-home message was, after going through all this rigmarole doing random response technique and unmatched count and standard direct questioning, they also did an indirect questioning strategy where they literally just said, never mind, what you do. To what extent do you think the average worker in your workplace does this nasty, horrible, terrible stuff, right? With that assumed similarity bias going, the tacit assumption is really they're saying, this is what I did. Obviously, a lot of folks are really going to grouse to hear that, but truth be told, in the IO settings, maybe what really matters is not, did you personally do it, so much as, are you perceiving it around the office? Are you perceiving it at this university, institution, mental hospital, business, whatever, right? So some target items that they actually use. To what extent has the average worker in your workplace used an illegal drug or consumed alcohol on the job? Taken an additional or a longer break than is acceptable? Come in late to work without permission? Oh, you anti-capitalist fiends. Intentionally work slower. Taken property from work without permission. Put little effort into work, right? And the tacit assumption is, if they say yes to these, that's in some ways, indirect way of assessing if they did it. I find that argument less than ideal. I've certainly worked with a lot of self-righteous people over the years who didn't necessarily do these things, but would be quick to accuse me of doing them, not showing up to faculty meeting. So I think in some ways this is an index of how judgmental you are. But as you can imagine, in a business setting, if the perception is everybody comes in late to work without permission, the time has come to intervene. I want to thank you for your attention on this. What I want to do is, based on this assumed similarity cognitive bias, kind of lay a foundation for Kane's article on hindsight bias, and I'll pick that up in the very next video. Love is boundless. Definitely take a break now, and I'll hope you can listen to that sometime soon.